so you know that this session is being recorded. Okay, so welcome everyone. My name is Mark Garneau. I am presenting today through my role in the BC AMT Executive. This is an initiative of the British Columbia Association of Math Teachers, as we wanted to provide some professional learning opportunities. Normally, we have an initiative, a goal to try to reach out to different groups across the province, and with us being unable to do so this year with the COVID restrictions and so on, we thought we would provide some of these learning opportunities virtually, which is, I guess, becoming the new norm, but hopefully a norm that will expire so that we can. I don't think we'll stop doing these kinds of things, but it'd be nice. It'll be nice when we can actually meet and do things face to face once again. So this opening image is, I just tried to capture something that indicated a routine. You know, the routine that this is how we go to, take a walk somewhere. There are routines that teachers use, but those are more behavioral kinds of routines. And for this series, we're going to be focusing on routines that are instructional. By the way, the slides that I am showing you today, there is a bit.ly address that I will share at the end of this session, so that if you want a PDF of the slides, you can get them there. So don't worry about writing all the details down and so on, or taking pictures or screenshots. You'll have access to all of these. And we hope to also have these materials like this video, the slides and other things put on the BCAMT website when that'll take place, or we'll let you know when that's all set to go. So before we get really into things and start doing some mathematical thinking, I'd just like to take the opportunity to acknowledge the shared traditional territory of the Coast Salish people on which the Surrey schools are located. And for Surrey, we recognize the Katzie and Semiahmoo First Nations who have signed the Aboriginal Education Enhancement Agreement. And of course, you are all in various places around the province, if not the country. I think we had some people outside of BC register as well. So we'd like to acknowledge those territories as well. So I thought, let's get rolling with this by jumping into a routine. This routine is called Which is Greater? It's sort of adapted from a book called Daily Routines to Jumpstart Math Class. There's a middle school and a high school edition. And so what's going to appear here is you're going to see two things put next to each other. And I'd like you to think about which is greater. And what that question means may mean something different depending upon what you are looking at, because I'm going to be showing 6 different ones. This is for a K to 12 audience, and I wanted to provide some opportunities for all. So just pick 1 or 2 to look at, and then, give it some thought. And to me, more important than your answer is what's your thinking behind the answer. So feel free to start sharing things in the chat as they come to mind. So here they come. So I'll let us look at this for at least a minute or so, and then we can see what sort of responses emerge. So feel free to report a letter in the chat and supply at least some kind of reason, even if it's very brief, for why you chose that one. Nice question, Tanis. Let's go with numeric value, as the case may be. Okay, I was wondering if any responses would start showing up, and now they're flooding in there. That's great. I encourage you to look at them. Obviously, as a classroom routine, we wouldn't be doing this with 6 different possibilities. We would just be doing it with one. Um, but like I said, I was trying to give things across the grades, and some interesting things emerge when we ask the question, which is greater? That yeah, like Chris just said there, E and F are the same, and yet for many students, for many people actually, between E and F, they might have to think about that first and maybe even figure it out to be able to make that comparison. So which is greater can have many different kinds of answers, and I think when we first start doing this routine, maybe we would do it where there is a definitive answer, and then as students become accustomed to the routine, which is what routines are about, getting accustomed to them, well, then we can start pushing the meaning of that question, which is greater? Because maybe they're the same, or maybe it depends. And for me, the more important question is, what is the thinking that goes into it? So even, for example, take a look at the different, like between A and B. I can compute the answers to these and then compare. But what I would want to draw out from the classroom discussion, or hope that it emerges in the classroom discussion, is that the first number went up by 9, whereas the second number only went up by 8. So if we look at the difference between those two numbers, we can make that decision without even going ahead with the calculation. In J and K, for example, we might just reason that, well, J, without even doing the multiplication, J is, each factor in the product is larger than each factor in the other product, and that's how we know it's greater. So there are tons of different kinds of things that we can do with this type of routine. And it's a way of turning a routine question, instead of just asking kids, what's 32 times 4, what's 42 times 3, to be able to engage them in, kind of a comparing situation and think about the underlying structure of the mathematics. It becomes a lot richer of an experience for them. So in light of this opening routine, I'd like us to think about the know, do, understand model upon which our curriculum is based. And certainly there's going to be stuff that connects with the know part, the content. But to me, the more important reason of doing routines is that it brings the competencies alive. They very naturally draw out the competencies. The competencies emerge. And that's probably a big reason why we chose to do a series on instructional routines, because, as teachers are working to shift their practice and trying to fulfill the curriculum that we now have, a really good starting place is even just trying to bring in some routines like this, because that's a way to bring the competencies alive as connected to with whatever particular content you may be exploring. So our series has these presenters shown at the bottom, and I will name them when I talk about which sessions are going to be in this series. But I thought this opening routine kind of addresses each of the 3 kinds of routines that we're going to be talking about in future sessions. So looking for similarities and differences. When we are looking at which is greater, we can look at each one and think, how are those 2 things similar and how are they different? And looking at those similarities and differences can help inform our decision about what we're going to answer. So we'll look more into those kinds of routines on March 31st. I will be presenting that one along with Amanda Russett, and we'll be doing routines such as which one doesn't belong, same or different, and at least 1 or 2 others. This routine also gets at sharing math thinking and modeling the notation, especially those numerical ones where, how we compare those even without calculating, how do we know that one is greater than the other? What are we thinking there? And what is a way that you could represent that thinking? Perhaps with between A and B, it's a representation on a number line. J and K, we could use some fraction models and so on. So there's a lot of thinking that's there. Oh, I'm sorry, I'm just pausing for, there's somebody trying to get in. I do not believe there is a waiting room, but let me just quickly pause this a moment. Let me see if there's such a thing as a waiting room for us, because I don't think there is. Okay, I will resume. Oh, I go forward, then back. No, I'll go forward here. Okay, I hope I'll clip that out of the video, hopefully. So we did that, and now we're talking about, slide along here. Okay, so that aspect, that kind of routine will be done on April 21st, and that will be put together by Janice Nowakowski, and she may have some help support for that. And yes, to answer the question in the chat, yes, you will have access to the slides afterwards for those just joining us. This routine also is a way of justifying a choice, because you're choosing which one is greater, or deciding that there isn't a difference, or that there's a it depends kind of a thing. So that routine is also an example of justifying a choice. And Chris Hunter and Sue Robinson will be looking further into that kind of routine. Things like would you rather, always, sometimes, never, and so on. And they'll be doing that on May 19th. Finally, on June 9th, we will have a wrap up and celebration. We'll kind of look back. We'll hopefully have some ways of people sharing, probably do some breakout groups, maybe introduce some other routines that we didn't get to, just as a way to complete the series. So our hope is certainly that people will attend the whole series. But of course, if you happen to miss one, then that's completely understandable. But we hope to see most of you at each one, and we're going to be giving you some takeaways in between, which I will get to momentarily. So, instructional routines. There's two parts to that phrase. There's the instructional part, and there's the routines part. So first, about being instructional, I think the important idea there is that we have to use them for a reason. So it's not just about doing something because we have this, like, oh, here's a nice routine, here's a fun routine, oh, the kids will love it, oh, my kids love it every time we do that. But why are we doing it? What is the purpose of doing something? And if our goal is about the learning, which is tied to instruction, we want there to be learning that is intended with an idea of what learning are we looking for, because that will help shape the conversations that emerge as we are doing the routine. Developing competencies. So and also putting those competencies into practice, I think, is a big part of that instructional goal of these routines. So speaking of the competencies, we have our mathematics curricular competencies are organized according to reasoning and analyzing. And all of the routines that we'll be showing is about making thinking visible, giving kids something to think about, giving kids something to talk about, and then that becomes visible. Understanding and solving. A big part of that is having different ways of approaching it and sharing those, and developing over time those flexible and strategic strategies. Why did you choose that strategy this time, and so on? Or how do these two strategies compare? Communicating thinking in many ways, or communicating and representing in many different ways, are something that emerged through these routines. And Connecting and reflecting, because as these ideas get shared, as the thinking is made visible, then we're making connections between them. Students are reflecting on, what do these other ideas that I'm hearing from my classmates, what do they mean for me? Does that make sense to me, or do I like to think of it in a different way, and so on? So all of these things are very rich in the curricular competencies, and of course, content as well. Routines are great for deepening that content understanding. And I'll make the further point that it could be curricular content or even non-curricular content. Um, a lot of them, it's very easy to find routines that tie in to what you're teaching. Um, although you may choose to use a routine outside of that time. So right now, if you're exploring measurement, it's still a good idea to bring in a routine that deals with some patterning, bring in a routine that deals with some number operation or that kind of a thing, because we don't just want, September's learning shouldn't just be for September. We want to keep revisiting these ideas, because as we revisit them, we deepen our understanding of them as we go along. But even if it doesn't tie in directly, there's still that purpose of of drawing out the competencies that makes it curricular. So even if the content isn't a direct fit, they're still worth doing, because of the competencies that emerge through that. From a routine aspect, I think they're called routines because they have a regular structure. Okay, they're you can, for each one of the routines, there's a way that they are presented, there's a way that they are used. So there's that routineness of that, and as students become familiar with them, they are able to become familiar with them, and that they get into that routine of doing them and knowing what is expected. They're usually brief, 5 to 15 minutes, depending on what they are. So they're not intended as, this is your math for the day, but something that could be integrated into the day, and maybe not even at the same time as your regular math class. Oftentimes, these discussions, the sharing of ideas, are oral. It's a lovely place to get to, where kids are able to, visualize in their minds what they're thinking about, and as they express themselves, the teacher can have an important role of representing their thinking, like on the whiteboard or some kind of medium there. So that's sort of the what of instructional routines, but to go through some of the reasons why, some of them have already emerged, like the instructional purpose of them. They are really great for building that community, a community of students where they feel safe to take risks, where they expect to learn from one another, where they expect to contribute to the learning of the classroom. It's an open place for everyone through these routines. They are engaging, not just mathematically interesting, but also because students engage when they feel they have a place, where they know that what they are thinking matters. Then that's a large part of what engagement is about. When students say, why do we have to learn this, or wherever we're going to learn this, it's not that they really want an answer to that question. What they really want is to feel like what they're doing matters to them, that they can make sense of it, that there's some meaning for it to them. Routines are practical. Like I said, they can take relatively little time, and there is a plethora of them available. And I do mean a plethora. And this is not an exhaustive list. And even within each one of these, there is tons and tons and tons and tons of specific examples of things you can use. So we're not going to go through every possible routine in this series, but instead we're going to pick the ones that we feel are the ones that have a longer track record, perhaps, or things that may be more easy for you to integrate, if you haven't already. And for those who have been doing routines so far, we're hoping that we can give you the opportunity to take that next layer of thinking about them, What am I doing these for? What are the real possibilities? What else can I do with them? How can we extend from them? And I'll throw in another reason, a good reason for doing instructional routines, and that is that they're very powerful for observational assessment. We can learn a lot about what individual students know and can do based upon what they contribute in a discussion as part of a routine. So with these goals in mind, we're going to take a look at another couple of routines, just general kinds of things. And then we're going to do some more examples based upon the upcoming sessions, just to give you a bit of a taste and flavor of what's coming up. So I'd like to do one from Estimation 180. And it takes that name because initially it was based upon a school calendar having 180 days. So it was having an estimation activity for every day. This is by Andrew Stadell, who's from California, and he's also presented for us at the Northwest in Whistler before as well. So here's the estimation that we are going to do today. So here is a quarter cup of almonds. And our question for consideration is, how many almonds are in the 1/4 cup? So as you are thinking there, I'd like you to think and make an estimate. And then I will model for you how we would play this out in the classroom. But I'll just give about 30 seconds. Do not answer yet, Grace, okay? And others, that's okay. Because I didn't say not to, but if I ask you, hold off the chat for a moment because we're going to play this out a little bit differently. So I'll just give you about 30 seconds or so. Okay, so with estimation activities, again, if for the benefit of those who aren't familiar with how these are intended to play out, I didn't say put numbers in yet. Just hold off a little bit. Thank you. And it's also hard to get kids not to blurt them out as well. So making an estimate, that can be a challenge for people and for our students. So one way of helping them to develop a better sense of estimating is first to, let's open it up to bad estimates, because bad estimates are a good thing. When we know what are bad estimates, then we can get better at figuring out what's a good estimate. So I would like to invite you to put in a number that is much lower than you think the actual number is. So what is a low estimate? Okay, thank you. These are great numbers. And there, yeah, you'll get everywhere from 1 to higher numbers. Deanna reacted to Minnie's answer. Minnie, that is a great answer. That we are confident that there is one. And so what we now try to do is, what's sort of the lowest number that we can have confidence in? So I think the highest low one I saw was 18. But is everyone so confident that there is more than 18? Would you be willing to give up your spring break if you're wrong? That's the kind of confidence I'm looking for. Okay, so then we might want to come down. And I see a lot of people said 10, and we could have some conversations about where that came in. There were some 15s as well, but let's say 10 is a confident low number. What about a high number? What's a high estimate? I'm waiting for Minnie to write 1,000,000. 2,000,000. Nice. All right. Okay, thank you, everybody. So looking at these responses, I see a lot of really great numbers here. I would probably start in the class discussion with 100 and say, all right, are we all really confident that 100 is too many? And if we're already confident, then I might come down, like somebody said, 50. Are we all super confident that there are less than 50 in there? Um, and are you, by the way, is anybody not comfortable with 50? Is anybody, scared to give up 50? Like if you're wrong, if there's more than 50, then you have to teach blended with 5 grades at the same time for the rest of this year. Maybe some of you already are. So confidence below 50. Okay. There are some other numbers here that I wonder if there would be confidence. Like 30, 22. So let's go with the 50 as a confident number. So what was our low? I think 10. So we've now defined a reasonable estimate as between 10 and 50. Okay. Do not share your more accurate estimate. Just make sure you individually have picked a number between 10 and 50. So I'll give you a moment to look at the picture again before you do that, and then we will have the reveal. Okay, here we go. A video is going to play. All right. So it turns out, and we could even have a conversation at this point about how many is that and how do you know? But in the interest of our time together, we'll just come out and say, so there's 28. So what this does is it validates that our estimates were reasonable. Everybody had a reasonable estimate because it was somewhere between 10 and 50. And as you play out estimation kinds of routines over time, the gap between the low and the high start to get closer and closer because kids are developing that ability to be able to estimate and start using the idea of reference, like, oh, I can see 5 there, and kind of visualize how many of that group might fit into something. And estimation is a really important competency to develop. So there are 28, but we are not done. So if there are 28 in there, then how many are in that new container? So without taking the time to play through this one, just to let you know how this would play out. So what I do is, again, invite some low estimates, high estimates, and then have people record what do they think there. And by the way, I personally have a really hard time with these kinds of estimating. But we can go a step further, and this is kind of like what's called a 3-act task, where um, I'm going to do you better than just leave it open as an estimate. I will provide you with some further information. And then I would ask students, okay, what would you like to know that would help you figure out how many almonds are in this new big container? So I will invite that part of the routine. So would anybody like to share a question? What would you like to know that would help you figure out or to estimate how many almonds are in the new container? Okay, how many cups? The volume? Okay, some agreement there. How much does it weigh? Ah, okay. So we could look at the total weight of the container and do it through weight as well. Okay. All right. These are good suggestions. So here's what I'm going to show you. I'm going to show you that uh, I actually answered both questions. Serving size is 1/4 cup, and there's about 40 servings per container. We also have a weight there of how much was in that 1/4 cup. So now that I've shown you the label, does that give you a way to figure out or estimate how many are in the total? I won't wait for the answer of that is hopefully yes. Uh, and so that now we can go ahead and get the actual answer. Not that there are exactly 1,120 almonds, but that is a close approximation. Because even from one container to the next, there will be some differences. And that's also a good kind of conversation to have. And by the way, I would also take this opportunity to discuss what are different ways that you could multiply the 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 40 times 28, which is what led to the 1,120. Because somebody might use a double double kind of strategy. Somebody might multiply by 30 and then remove the excess. Somebody might use place value to do it. So there's a lot of rich mathematical possibility here. And I'm just realizing now that in that 1/4 cup, if that's 28 grams, then every almond weighs about a gram. Hmm, did not realize that. Okay, here's another type of routine that I wanted to do because uh, a lot of routines look like they're just about numbers. And I wanted to give an example of a routine that is from a very different strand, and that is the data and statistics strand. So this is a routine called slow reveal graphs. And instead of showing you a graph of some data, we strip away a lot of things and gradually reveal things. So at this stage, I'd just like you to look at the graph and just think about, what do you notice about this graph? What are some things that you wonder about in this graph? So without getting into, taking the full time of going through this routine, I'll just have you keep those ideas to yourself for the moment. But I would like you to think about, what do you think this graph could be about? So now I'm going to share the first piece of information. Okay. So how does this new information help us? Does it give you any further ideas about what this graph may be about? Or is there something new that we learned about this set of data? I'll invite anyone if they want to contribute in the chat there. Perhaps there may be a wondering of what year is this? Okay, that's all right. Thank you, Jan. So Grace, yeah, 2021 would be interesting. Okay, yeah, because yeah, how would I know what's going to happen in July, August, and September? So in fact, so that there's nothing in this graph that says what year it is. It could be any year, but it does seem to, the sort of things falling quickly and staying low does seem to have some connection to 2020. And in fact, that is the year. And so just take a moment now and think about, what do you think this data could be about? What do you think is being graphed here? because there are any number of things that it could be. Mm, yep, great responses. Yeah, these are wonderful. Like if you think about this kind of conversation in the classroom, it gives, kids an opportunity to reflect and really think about, what has been the impact of this global pandemic. Um, Ooh, precipitation. That's an interesting one. So there are other things that come into play here as well. So, one of the competencies is about how does, the math connect to our real life, our world around us. And so all of these things that impact our life, we can we can see the connections here. So what this is, in fact, is about the US box office gross. And I only chose the US because I had ready access to that data. I was readily able to put that in there. So that's what this is about. And I'm next going to show you some. So first of all, I want kids to, does that make sense that the data would look like this? And sort of, we could, even before getting into any numbers, we could talk about, why is it almost nothing here at all? Why does it then climb back up and then maybe a bit back down again, and make those connections to what was really going on in the world? Next, I'm going to give you some numbers. Okay. And then now that we have some numbers, I might ask for some predictions. And so here's an opportunity for some spatial thinking, some proportional thinking according to shape. Again, so in the interest of time, not going to play this out exactly, but as you're thinking about it, so the next stage of the reveal would be to reveal some numbers here. Okay, and hopefully those numbers make sense. To me, the one that would be the most surprising, perhaps to some students, is that July is at 8 million, because $8 million, that's a lot of money. But compared to the scale, like compared to 900 million, it is very, very tiny. So $8 million compared to $0 million might mean a lot to us, but to the movie industry, it's really barely much of a difference. And so finally, we get to the final reveal of all the rest of the data. And we might have some predictions. What do you think this could be? What do you think that could be? And so on. So from a routine perspective, and I love this one, A, because it deals with something that to me is one of the most common ways that mathematics is seen in the world, and that is as presented through data and graphs. Such a huge, key, important part of numeracy. Um, but also just to reflect on, you know, in the past, maybe we've given finished graphs before and we ask students to interpret it. How does that month compare to that month? Describe a story of what's happening. Um, or we've given them the data and asked them to graph it, in a bar graph. But the data has much more meaning through this sort of gradual reveal because we're kind of forced to look for relationships, look for trends before the numbers get in the way. So a really nice, powerful routine. All right, so back to our schedule for the series. As was said, and I saw in the chat, people were wondering again, and like I said, the slides will be shared at the end. So um, what I'd like to do now, though, is just quickly go through an example or two, or an example for each one, just to give you a little taste of what these different routines look like. So similarities and differences. The most common one that is widely, hugely popular is which one doesn't belong. And here's one that I made recently. So through this routine, um, it is really about looking for similarities and differences. And and even defending a choice could fit into this as well. So what do we notice about these ones? And this isn't necessarily a very mathematical conversation, except that it does connect. What do we do in mathematics? We look for properties. We look for things that are, patterns and things that are the same and things that are different. But the idea of a which one doesn't belong is that each one has something about it that makes it able to be excluded. So yes, as Jan said, the bottom right is the only one where he's sitting. The bottom right is the only one that went viral. Bottom left, not wearing a mask. Top left, arms behind, although it's a little hard to compare with the bottom left. Yeah, bottom left, no mask. Bottom left, close up. All the other ones are further away. So every time you identify a difference, ooh, I like that hair blowing in the wind. Yes, look at all this great thinking coming out. This is fabulous. So notice that every time something gets mentioned as a difference, it is also a similarity between the other three. So in calling out the fact that Bernie is sitting in the bottom right, that difference points to a similarity between the other three in that he is standing through all of them. So this is just a great routine, goes very quickly. There are lots of ways of being able to uh, facilitate these in a classroom. But in order to find out about those, you will have to come on March 31st. But just to give some other examples, just to show how they can span across different grades, different topics, whether it be about shapes or numbers, graphs, really any kind of thing where you can look at similarities and differences is an opportunity to do a which one doesn't belong. So we'll also look a little bit, we'll peel off the layers a little bit next at the end of March and think about, how are they created? What is the intention behind creating one as well? Because it isn't just a random selection of four things that are kind of alike. There's more intention brought into them. So we'll unpack that a little bit at the end of March. And that'll be a session that Amanda Russett and I do together. Um, in April, Janice will be again about sharing math thinking and modeling notations. And one of these routines, one that I love to use a lot, is number talk images, where it's just about showing an image and asking the questions, how many do you see and how do you see them? And the first question is not as important as the second question, because the rich conversations, the rich ways of thinking are going to come out of how do you see them and what sense do you make? And so for each of these, kids might see different things. Both of these are images where what isn't shown can be a helpful way of figuring out how many. Just pause there in case you're wanting to come up with a number for yourself. And by the way, on these slides, I'm putting the website where I got them from in the bottom right, just in case before, the other sessions, if you want to go try some of these things out or go look for them, then you have a place to go do that. All right, the session in May about justifying a choice, that which is greater routine that we looked at earlier is an example of that. Would you rather, even using the clothesline activity, which Chris Hunter and Sue Robinson, they're going to be going through these, always, sometimes, never. I love that routine. I'm going to choose a different routine here, and it's not clear right away why I chose it for justifying a choice, but it'll become apparent, I hope. But it also turns into a richer inquiry routine as well. So I'm going to give us a little bit of time to look at this one actually. So consider the product of 24 and 21. I'm going to bring it down again because I want to do something to these digits. So watch very carefully. Okay, see what I did there? Now, I'm going to put these next to each other. And I wonder, are they equal or not? So it's not much of a choice. I'm giving you a choice of yes, they are, or no, they aren't. That's my initial question. That is your choice. But of course, I'm much more interested. I'm not as interested in the answer of yes or no, or agree or disagree. I'm interested in what do you see that informs you that you know that they are, or you know that they're not, especially even without calculating. So I'll open it up. I'll let you think about that. You're welcome to post an idea in the chat. Agree or disagree that they are equal, and provide a reason for why you know. Okay, I'll just let another idea or two slip in there before I make any comments. Okay, we've got lots of good ones here. And without going into great depth, I see Janice, thank you for coming. I know you had to leave early. I'm sure you can catch the rest of it in the recording, and we look forward to your session in April. Notice what's coming out of this is a lot of different strategies, and this is the power of doing a routine. We get to see all these, and hopefully with some of this, like, oh, I didn't even notice that, or I hadn't thought of it that way. So looking at the factors, and I will tell you personally that I didn't even think about the factors, and yet that's what is happening when we're looking at a number. We want to see, when we see the number 21, we don't just want it when we're multiplying. We don't just want to think about it as 21 or as two tens and a one necessarily. We can think of it as a factor of 3 and a factor of 7. That's a powerful way of looking at a number. Looking at the structure that, in terms of multiplying by tens, you get the same product. And then following that up, I saw Julie follow it up with same with the ones, that 4 groups of 1 and 2 groups of 2 produce the same product. There was this double half strategy that emerged. So yeah, area model could be shown as well, and showing how those two area models are related to each other. And that could help actually visualize the double half strategy. So there's a lot of rich thinking that goes into this. And then some routines can even launch into further investigations. So what I have in mind here is I would want to explore some different things that could emerge from here. So, does this always work? Can we just switch the two numbers of any product and will it equal the same thing? Convince me that it does or that it doesn't always work. When it does work, why does it work? Does it always lead to a double half strategy? Or what else is going on there? So now all of a sudden, what started as a simple routine can turn into a much bigger investigation. And this content wise, this is grade 5, but it could also be something that could be explored in grades larger than 5, because even though they've done two-digit multiplication in grade 5, there are greater depths of understanding of that content that you can get into, that you want to keep, bring alive. I'm still learning more about two-digit multiplication, even though I took grade 5 a few years ago. Um, I also wonder about, what if we converted these into algebraic structures? Is 2x plus 4 times 2x plus 1 the same as 4x plus 2 times x plus 2? If so, how do we know? If not, why not? So I'm going to leave that one there. So a lot of the justifying a choice routine are a lot more, there's a lot more going on than just the choice. It's all of the thinking that comes through it. And the same can be said for all of the other routines as well. Okay, so here are the sessions again, and the way each session will play out is there will be some opening reflections from the previous session based upon something that you were maybe asked to try, exploring the what, why, and how of whatever that routine theme is, with some examples, and then some kind of takeaway, something to try before the next session. So this is our first session. So there is a takeaway, something I want you to do between now and March 31st. And the first thing is, enjoy your spring break. That is a very important takeaway from this today. It's March 10th. We have our break coming. Enjoy it. You deserve it like no other year ever. So enjoy that. That's your big takeaway. And while you're enjoying your spring break, something you might want to think about is where you can weave routines into whatever plan you have for mathematics. Again, if you don't do that, that's fine. Your primary objective is to relax. But as you maybe think about some of the experiences we had through this, then you could think about, I wonder where I could fit those routines in. Or if you are doing them, think about, how is that working? How is your current plan for routines working for you? All right, we got a minute or two, so I'm just going to wrap up. A couple of links I'll share. This one is to the Surrey Schools numeracy page that we put together for the during teaching during COVID times. So we have a link to a whole bunch of different routines there. And by the way, there are many web pages that have a set of links. But I also wanted to draw your attention to the BC Numeracy Network, which has a lot of people from around the province. They are an amazing group of educators. It includes some people who are here today as well. That site is a wealth of things. And what I really like, when you find the part that deals with routines, it doesn't just give you links to routines. It actually situates that within the context of, what is your intention of using this routine? And what are some key ideas about that? And one of the things that they put together to help with that are these routine cards. So it's a set of cards of different kinds of routines. They have a front and a back side. They have some descriptions of, why is this routine important? What are the key elements of this routine? And so on. And they come on cardstock, so they're durable and thick, full color. They look amazing, and you too can get your own set. They are $10 a set, and that includes shipping. Okay, I guess I should say it's free shipping to make it sound more enticing. And if you just email Sue Robinson, her email is provided there, then she can arrange to get a set mailed to you. So again, on the next slide, I'll share an address where you can get these slides, and that way you'll have this information on how you can get your own set of some routine cards. So there it is, this bit.ly over here, bit.ly/BC routines 1 is a Dropbox place where you can download a PDF of these slides. And if you're not aware, bit.ly addresses are case sensitive, so BC needs to be capitalized, routines needs to be lowercase. And that is 4:30. We are done. Thank you for joining us. I will stick around a little bit if anybody has any other questions or things to ask about. But otherwise, enjoy the rest of your evening, enjoy the rest of your week, and have a fabulous spring break.